So let's take a look at the limit at low frequency. What happens at we've shown that it does go to 0 at high frequency, right? What happens at low frequency? Here's your expression right here. Okay. You recall your power series expansion for e to the x is x to the 0 over 0 factorial plus x to the 1 over 1 factorial plus x squared over 2 factorial and so on. Okay, so that's it. So x to the 0 is what? 1. And what's x to the 1? What is 0 factorial? Just 1. So that's just 1 right there. X and 1 factorial is just 1. So that's the second term. The third term is x squared over 2 factorial. What is 2 factorial? That's 2 times 1, right? What's 3 factorial? 3 times 2 times 1. So that's the expression, the power series expansion for e to the x. Now, what happens as frequency approaches 0? H nu over kt is x, right? Now, so if nu approaches 0, what happens to your x? X also approaches 0, right? Correct? So, what happens with e to the x minus 1 if x becomes very small? Look at this expression right here. Yeah. The small, like if you go like x is 0.1, what would x squared be? 0.01. X cubed would be 0.001, right? But if x was like 0.0, okay, if x was like 0.01, what happens to x squared? 0.00001, and x cubed would be 0.000001. So these higher order terms tend to drop out, tend to become negligible as x becomes very small. So you can say that e to the x, okay, your e to the x approaches 1 plus x at very low values of x. So we're going to make a substitution then. As we're approaching x equals 0, this e to the x is going to approach the expression 1 plus x. But what is e to the x minus 1 then? What is 1 plus x minus 1? It's just x. Okay? So, if that's the case, our expression will then simplify. What is rho as x approaches 0? Approximately is equal to 1. 8 pi nu squared over c cubed, okay, h nu over, instead of e to the x minus 1, you're just going to have x, which is, what is x? H nu over kt, right? So instead of e to the x minus 1, you just have x. So, and so what happens? Cancel h nu, and what do you get? You have 8 pi nu squared over c cubed times kt, which is the Rayleigh-Jeans expression. So you get agreement at low frequency, you get agreement at high frequency.